In this unit, we're going to look more into the periodic table and the organization of the periodic table, and looking at the types of elements and sort of why they have their properties. So periodic law says that when you put elements in order by their atomic number, we tend to get this periodic repetition of their physical and chemical properties. That's why it's called the periodic table, is because of the repetition. Mendeleev actually was the first person to really organize and come up with the first periodic table, and he organized the periodic table by properties and by the actual mass. But now we know if we put them in order by atomic number, that's where we get this repetition. So the horizontal rows in the periodic table are called periods. There's 7 of them, and they actually correspond to the number of energy levels, as we learned in the last unit when we used the periodic table to figure out our electron configurations. The groups are vertical columns, so they're also called families because they actually have similar physical and chemical properties, and they are identified by different lettering and numbering systems just based on what kind of periodic table you have. So if you look at the ones at our periodic table here, we have our rows, and most likely yours are already numbered because of doing the electron configurations in the last unit. So there's 7 of them, 1 through 7. But then if we look closer, it's kind of hard to see, but let's kind of zoom in. You can see there's different numbering systems at the top of the columns. So this says 1 or 1A. This is 2 or 2A. So the 2 different numbering systems we have is from 1 all the way to on the right hand side that goes to 18. Over here 18, or we have the A's, which are 1A, 2A, 3A, 4A, 5, 6, 7, and 8A, which those tend to be a little bit more useful for us in the ones that I use. And then we have the B's down here, where these are all just considered transition metals, which I'll talk about in a second. So remember that your periods are your rows, and they correspond to energy levels, and then your columns are your groups and your families, and they have similar physical and chemical properties. Now, another way in which we divide up the periodic table is based on 3 different distinctions or classes of elements called metals, nonmetals, and metalloids. So metals have similar properties. So metals tend to be good conductors of electricity. They have luster, which means they're shiny, and they're also ductile and malleable. Ductile means they can be drawn into wires, and malleable means that they're bendable, so they're really kind of soft. And we'll look at the atomic structure and what's called a metallic bond and sort of how those properties arise in a second. So nonmetals are opposite. They're generally brittle, which means like if you hammer them, they'll shatter or break. They're not shiny, and they're not very good conductors of heat or electricity. So a metallic bond is really what holds metals together. You have just a bunch of metal atoms that come together in the form of a solid, and the valence electrons in each one of those atoms is sort of loosely attracted to its nucleus. So those valence electrons can actually flow between different atoms. So we tend to say that metals are like a whole bunch of positive ions, which basically that just means a positively charged atom. Which comes from the nucleus, and a sea of electrons. So if you kind of look at that, your nucleus has all those protons in the center, so that's those big red balls that you see there. And then the white dots represent the electrons, and they're just kind of flowing in between the different nuclei that are next to each other. So they are free to flow, so conducting electricity, electrical current is really just when charge moves from one place to another. So that's why they make good electrical conductors. This also is what gives them their properties of being malleable and ductile. So malleable, like I said, is where you can be hammered into a shape and bend, whereas ductility means you can be drawn into wires. Now, those properties, especially the hammering one, a lot of times people envision metals as being hard, right, and rigid, but they really are, they tend to be very soft, and if you heat them up, they're very bendable. And this is because a lot of the metals that you encounter on a daily basis are actually alloys. They're not pure metals. An alloy, remember, is a homogeneous mixture of two or more metals. So we made brass alloy when we melted copper and zinc together in the alchemy lab. Bronze is copper and tin. And they tend to have a superior properties or different properties than the pure elements themselves. So sterling silver is another example. That's a mixture of two metals. It's harder, more durable. That's what makes sterling silver good for jewelry and for silverware and stuff like that. Steel's also a type of alloy. It's very known for being very strong because it's a mixture. It's not as corrosive, so it has a lot of properties that make it beneficial to using a pure element. So that ductility and malleability really comes from the movement, the ability for those electrons to slide past one another. So to make a wire, we basically just force a metal through a die, which is another piece of metal that has a small opening. And so you kind of progressively make the metal thinner into a wire. Whereas malleability is sort of shown here, where you have these like sea of electrons, and if you were to apply a force, the electrons can sort of slide past each other, so that they change shape without breaking. So here, if you just apply a force, you can see it sort of slips almost like a ball bearing so that it doesn't break. So let's go ahead and look at the periodic table that you have in your reference packet, so we can look at where those metals, nonmetals, and metalloids are. So let's get out of this and go over to the Elm real quick. All right, so if we look, there is this stair-step line right here that sort of separates out our metals and our metalloids. Metals are over to the left-hand side of the periodic table, so I'm just going to circle them in pink. They're everything over here, and I'm going to be careful to make sure to include the correct ones here. Aluminum is a metal. All of these. Although hydrogen is over here, it is not a metal. These guys all down here are metals as well. So this is all metals. Then up and to the right is where we see our nonmetals, and then also hydrogen. Hydrogen is a nonmetal, and then we have, I'm going to be careful here not to include the ones that are sort of in between. All right. So these guys over here are all, let me use a pen, these are nonmetals. Now, the elements that sort of fall in between a metal or a nonmetal are metalloids. So these guys right here that fall along this dark bolded line, which we call your stair-step line, are metalloids. So that includes boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. Ooh, polonium's a metal too. Right? So they have properties that are somewhat in between. So like silicon and germanium are metalloids that are commonly used in electronics because they're considered semiconductors. They're only sort of good at conducting electricity. They're also shiny, but they're brittle, right? So they have some brittle, which is a non-metallic property, and then shiny, which is a metallic property. And actually I have you look at silicon in one of the first worksheets that you do. So that's one of the separations of how we classify elements on the periodic table. Now, we've already learned what these boxes mean and everything within these boxes. So just quickly again, you have your element symbol, you have the element name, you have your atomic number, which is your Z number, your number of protons. We have the average atomic mass, which is the average of all the masses of the isotopes that we have. And then some periodic tables have these little numbers up in the corner that corresponds to their electron configuration. Our periodic table doesn't have that. All right, so like I said, some of the groups or families in the periodic table, or all groups or families in the periodic table, share similar physical or chemical properties. And so there's a couple of groups that I want you to be aware of what their names are and kind of what they have in common. The first is group 1, which are called the alkali metals. And they're called alkali metals because alkali is the opposite as acidic. So they actually form a base when they are reacting with water. Group 2A, those are called alkaline earth metals. So again, they are ones that form bases when they react with water. They tend to not dissolve well, which is why they're called earth metals, because we find them sort of as hard deposits in the earth. Group 7 are called halogens. The prefix halo means salt forming, and we'll actually come back and sort of look at why they're salt formers and what a salt is later. And then the last group that I want you to know the name of are noble gases, and these are in group 8A, or remember also the numbering system 1 through 18, so it would be in the 18th column all the way off to the right. They used to be called inert gases. They're very stable. They don't react. They have a full S and P shell. All right, so let's just look really quick, and I'll label those parts on the periodic table, and make sure you sort of have them labeled for your reference, then we'll be done. So group 1A right here are alkali metals, so alkali metals. And remember, we don't include hydrogen in that. And then group 2A are our alkaline earth metals. And then over here, these guys don't really get names. Our B, or our D and F block, those are called transition metals. Sometimes they're called a group. These guys don't really get names. They're a mixture of metals and metalloids. Sometimes it'll be like the boron group or the carbon group, just because that's what's at the top of them. But then we have 7A, which are our halogens. And then our last group, group 8A, I'm kind of running out of room here, but we'll just put it right here, noble gases. All right, so that's a quick rundown to the intro to how the periodic table is organized.